Good morning, viewers. I'm Stephen Okuta. Once again, I'm very happy to go with you through the learning process, even as we are facing the current problem that has been seen all over the world. So last time we were with you and we discussed on the external land processes, and these ones was shown by first looking at the process of weathering. So we'll still continue with the external land processes, and for today we'll start by looking at the process of mass wasting. So the second topic we are going to look at is mass wasting. So what is mass wasting? What is mass wasting? So learners, you've ever heard of the experiences people normally go, especially during the rainy season. Like in Kenya, we've seen areas of at the North Rift, you've seen the Pokot, areas of Pokot, areas of Marakwet, experiencing some kind of damages that have been done as a process of the land moving or the mud moving and covering people. So this has been experienced in so many areas in Kenya, even in central area where houses have been submerged due to the land moving processes. So for today, we are going to look at mass wasting, and mass wasting is one of them that has caused or that has led to people losing life and to some extent even property. So let's start by defining what mass wasting is. So learners, mass wasting is in the category of physical geography, and if you can see in your screen, when you see by time, if you've been young and you've seen a kind of erosion that has occurred, especially to areas that are hilly and areas that are sloping. So the kind of movements that have been seen over time. So this can occur, it can occur within the shortest time possible, or it can even take a very long period before you see. So normally some will move within a period of 1 centimeter per year or per annum. Then others will take a rapid movement, and this all depends to the occurrences or the processes that are defining the factors that follows. So external land movement processes is very key, as it takes part of our life, it gives us new features, and as well as it can cause damages to our property or to an extent of losing life. So what is mass wasting? Mass wasting has been defined as the soil or rock debris, or we call the bedrock. Bedrock sometimes can be called the parent rock, that move in bulk at the earth's surface. So this is called mass wasting. Even to make it shorter, you can define it as the movement, the process of movement, or the process of the movement which is controlled by the gravity. So here, when things move from a higher region to the lower region, the key factor that acts in the terms of movement is what we call the gravitative force. This is a force that pulls things down. So learners, be assured that whenever you talk about mass wasting, force of gravity is a key factor. So let's continue. The movement of the materials, it can be ice, it can be rocks, it can also be soil. So there are factors that lead to the erosion of these materials. And last time we talked of weathering. So in weathering, we say it's the disintegration of the materials, this from the parent rock or from the bedrock materials into the smaller fragments. So these are the smaller fragments that are moved. So the materials or the debris that are moved from the higher region to the downer slope, that process is called the mass wasting. And we've said that gravitative force is the key factor here. So it depends with the incline or the angle of the slope that can either speed it or can slow it down when things move. So it's important to know that. Now, why is it important? On average, the form of mass wasting such as landslide, you've heard of landslides, mudslides, and even avalanches. Avalanches are the movement of ice. It happens, ice or snow. It happens when there's a slab of snow or ice that has a weaker joint. So it slips over the weaker joint and moves down. That's what we call avalanches. It's actually account for more loss, can lead to the damages of life. If they say it can loss of life, property damage, and it can even be worse than the earthquakes or volcanoes. Now, whenever you see the process, it's very important you know the key indicators of whether there's a likelihood of mass wasting to occur. So these are the signs. The signs can be when you see homes cracking. If you see cracks in your home, especially when you are living in hilly areas, or you see the cracks forming within the land, know that there is danger. Apart from that, you can also see the breakages of the debris collecting down the hill. That's another sign that there's a process happening up there. So whenever you see this process, please move away from the area because a disaster may occur. And when you see there is no cohesion forces pulling up things together, that is a sign that there is likelihood of an event to occur which can be catastrophic or can lead to the loss of life, and life is very, very important. Now, let's continue. When we are talking of mass wasting, when we are talking of some wasting, the force that we've said that act is the gravitative force, which is key, and this force occurs under different factors. So one factor that controls gravitative force is the weight of materials. There's the weight of the material. When we talk about the weight of the materials, if something is heavier, then it's likely to attract more gravitative force. It drops down very fast at a high speed. And when something is lighter, it is likely to drop down slowly, and that can lead to different formation of impacts. So impacts can occur due to different weights that are exerted by objects. So if the rock is big, it's likely to give a bigger impact and compare to a debris that has been peeled from the parent rock material. So it depends with the weight. Then the second one is the normal force. That is a normal force, and the normal force of an object will be controlled by the angle of the hill or the angle of the surface. So we say there are slopes that are slightly inclined, others are sharp, others are steep. They are the steeps that they form gives the different types of the impacts that is likely to occur as a result of an object. So we've said an object, if it is heavy, it is likely to drop very fast, and if it is lighter, it takes time. And with the second one, the normal force, it depends with the angle of the slope. So if you are working on a flat surface, then the movement can be slow depending on which direction the slope is facing. And if the surface area is hilly or it has a steep sides, then the object is likely to fall faster because the gravity force will be pulling it down faster. Now, there is another thing called the shear force. That is the parallel gravitational force between the object and the slope. So when we are talking about the object and the slope, we say that it is very, very important to see how it works. Now, if this is a surface, and then within this surface you have a land surface like this, then if the debris spills here, they move towards this direction, and then they're collected down there, the downer slope. So these are the debris that are collected down here, the ones that have spilled from here. And if you have another surface like this that has a sharp end, then if a debris pulls out from this point to down a part, it is likely to move faster compared to this, because this one is a gradual slope, but this one is a steep slope. So that's what we are talking about. And if you're working on a flat surface like this, then the debris can easily move, or sometimes they can stay in situ because there is no force, there is no gravitative force to pull it down. And that's why I've said in this case, force of gravity is the key factor. Then we have friction force. You've seen the friction force occurs when two objects rubs against each other. And that's why we've said if you have an object that is compact, then this means the object is likely to resist the movement. But if you have a weak joint, then an object will pull us, like avalanches that I've talked about. When you have a weak joint, within those weak joint, the upper part or the lower part will pull. So as it pulls, it rubs against each other, causing the frictional force. So it is this friction force that can sometimes cause us damages. So as the debris moves, as they move, they crush everything, creating the frictional force. So within those frictional force, they are the ones that damages the properties that we have. Errors sometimes can even crush the living organisms or the people that are living around. So it is very, very dangerous. And mark this, gravitative force is the key factor in the movement of the materials. That is from the higher region to the lower region. Now, having looking at how the forms of gravitative force, how it acts, and we've said the factors, the underlying factors that controls it are the weight of the material, the normal force, the shear force, the shear strength. The shear strength, that is the cohesive strength. When materials cannot be broken, if they have that bond that keeps them together, then they are likely not to break. But if they are weaker, they can break. So when they are breaking, they cause what you call the frictional force. In other words, all these things are related. The weight of the materials, the force, the normal force, then the shear force, shear strength, the last one is the friction. So the next one is water as a factor. Water as a critical factor that can cause mass wasting. And it is very important, you know, and that's why I've talked to you about what you saw in the North Rift that killed many people, and what you saw in Central region that caused loss of life and damages to the property. If I can give you this example, back at home or in our rural context, even in some areas of the urban region, you've seen houses that have been constructed by using a paste that is made from the soil. So it is this soil that is mixed up with water to create a paste, and then this paste is the one that is used for spearing or making up mud houses. So this is it. When you use excess water when mixing up the soil, it is likely that it will not withstand the height. It will be pulled down because it is the bond that has been created between them through the mixture of water is somehow liquid. So it makes it very difficult to hold. So when you use excess water, it forms something, is like you're cooking porridge. You transform water when you're when you have boiled your water, then you add flour. You add flour until you make it concrete, you make it strong. But if it is not strong, we might call it, this is porridge. You can say this is porridge. And that's why we say we eat porridge. We don't drink porridge, we eat porridge. So it's very, very important that you know that water is a key factor. If you use excess water, it cannot hold. The weaker points are formed. There are so many weaker points that are formed that cannot withstand the force of gravity. But when you use little water to make it standard, then it can withstand. And that is the difference. So that's why you see when the higher regions are hit by rain, the mud or the debris are washed down. So if it is not excess rain, if it is not it has not rained heavily, it's likely to withhold. But if it is excess, it causes the surface area and the underneath layer to form a weaker point, whereby the surface area that has been waterlogged slips away from the higher region, the lower region. And this also happens to the areas where there's kind of drainage system. For example, along the riverbeds. So when there's excess water, the debris are collected, or the sides, the banks of the drainage system are washed away, and then they are swept and collected in an area that is flat. And this is very key, and that's why you say in areas of Kano, areas in Kisumu County have experienced flood, and sometimes these floody areas, they normally leave damage in terms of the collections or the deposition of the materials that have been washed uphill, washed by the river, and then dumped into the people's homesteads. So it forms another layer, and this has been experienced over and over again. So water is a key factor. Now, there's another thing which is called water. No, it's just still water, but it forms another thing, and this is it. When there's too much water, it reduces what we call the shear strength. It cannot hold. So these particles, they lose what we call the cohesion force, or the friction force that pulls them together. Again, water also adds weight. So when it adds weight, and what did we say when you are starting this? We say that when there is a greater weight along the slope, then there's likelihood that an object will fall faster, or a part of the debris will fall faster, because weight has been added. Lighter materials will move slowly, while heavier materials will move faster. So this thing, it is very important that we grasp every details of mass wasting and concentrate it in relation to the gravitative force, water as a factor, and the kind of material or an object that has been acted on. So it is very, very important. Again, water as a factor causes what we call freeze and thaw. This is the breaking up of the material. And you've ever seen when you are talking about weathering material, things that are caused, we said that when water is cooled down, yes, when water is cooled down, it contracts, but when it reaches 4 degrees, it expands again. And we gave an explanation of that. So the process of expanding and contracting, causes the materials to lose their cohesiveness, their bonding. So when that bonding is lost, it leads to the breakage. And these breakages are the ones that leads the formation of the debris, which moves from the higher region to the lower region, or even in a flat area, but washed away by the drainage system, especially water. Now, there is this again. We've talked of the expansion and construction that is caused as a result of the freeze and thaw. There is what we call the triggers or the controls. What triggers the mass wasting? What are the controls? So we have a number of factors that leads to the extreme mass wasting or the normal mass wasting that has no damage. So let's look at number one, the steeping of the slope. And I gave you an example. With this different environment. I gave you that. There's another one. Let's say that is 1, 2, 3. So this is 1, this is 2, this is 3. So we have a flat area. Then we have an area that is slightly raised. Then we have an area that is sharply raised. You see, so the angle of the steep, we can say here, because on Earth we normally say there is no place that is straight. There is no place that is straight on the Earth's surface. So if this is a place, let's say it is slightly raised or it is irregular, but it's somehow flat. So when materials move here, the distance or the movement of these materials, they are likely to take time because the force of gravity here is weak. It is weak because this place has not been inclined. Then case number 2, we have if surfaces move from here, then they are likely to move down here or even here at the lower surface. But the speed is likely to be slow because this place is slightly raised. It is slightly raised. So it doesn't cause much of the gravitative force. And we've said force of gravity is force that pulls things down. It pulls things down. The force of gravity. The force of gravity is the one that pulls things down. Then take a case of number 3. So if you had your house here, down here, and then the debris breaks from the topmost layer to the downer part, it is likely to cause the damage because here the steep attracts a lot of the gravitative force, leading to the greater impact. It leads to impact and damages. So be very, very careful when living in such an area. So normally people are discouraged to live in these areas because they are likely to get damages or they are likely to lose their life because of the gravitative force that pulls down the materials that have broken from here. So when you are from here, you said areas which are hilly, they can either attract snow or they can even attract rain. And we always say that in a mountain there's a leeward side and a windward side. So there's one side that receives excess rain, the other one that doesn't receive excess rain. So this concentration of moisture up here that can either lead to the formation of rain, and we normally say that the rain that is formed as a result of highly raised areas is called the relief rains. So these relief rains, the concentration can be done here to reduce the cohesive force, leading to the breakages of materials down part here. Again, they freeze and thaw water that collects up air. They contract, expand. They contract and expand. So this process weakens the bondings, and therefore the materials are likely to break down. And if you are talking about snow, if snow was concentrated here, then it causes what you call avalanche, and then we say avalanche is caused when there's a weaker slab of snow and the stronger part, and within there's a weak joint that separates them. So it is this weak joint that makes the upper part to slip away. What we are saying is, if this is a slab of a snow or an ice, and this is another one, and between my two hands here there is a weaker joint here, then one, it slips down. If our area had an inclined shape like this, then this side will slip down, leaving the other part that is attached to the mountain. So this is what can cause damages down there. This is what carries the debris down apart, and this is what can cause the movement of materials. And remember, it moves as a result of the gravitational force. So I think you are clear there. Now, the next one is the classification of mass wasting. The classification of mass wasting. So we have different types or different ways to classify mass wasting. So number one, they are classified by the type of the material. What are the materials that lead to the classification of the mass wasting? So number one, we have the type of materials, but under the type of materials, we have what you call the debris. The debris are the smaller, let's say this is our land again, and the whole of this is parent rock. This one is parent rock, or we can call it bedrock. This is bedrock. The whole of this is bedrock. So the materials that split from the parent rock material as a result of that or weathering, these debris that moves down, that the ones that are known as the debris. These are the debris. So these are particles that are extracted from the bedrock. So the debris are called unconsolidated materials, the materials that have broken the bonding and are collected or washed down the hill. Then the second one is the bedrock. So the bedrock is a solid material, that gives birth to what we call the bedrocks as a result of the processes of weathering that we had explained before. Then the second classification is by the type of movement. And example that we've given is that when we talk of things that are the materials that are caused by the type of movement, then we talk of the flow, the slip, and the fall. So under the flow, there are materials that are viscous fluid. So it depends with the concentration of the liquid, the ones that dissolve them. And we've given an example, like if you had your water before preparing your ugali, what happens is this. Water, when you spill water, it moves faster and it covers a larger area because it is liquidish. It does not have so much mixture, and that's why we say if you are using a house that has been smeared by mud, and whenever you're making that paste, if you put so much water or excess water, the soil will not hold. It will go down. It will be pulled down by the force of gravity. And when you transit water to porridge, then if you spill it, it will move, but not as water. And again, if you now cook your ugali, it will move as a solid substance. And again, it will not go far compared to how water has moved. So it is this concentration that defines them both. So the one that has so much concentration of water moves faster, and that's why you say in areas, the hilly areas of the Mount Kenya regions or of the North Rift region, they are likely to face the damages because when excess water heats up the upper region, it washes away the debris and it covers a bigger area. And you saw that the damage, even some of the police officers were washed away. Some people were to be extracted from the mud. They were buried by the mud because the water was in excess. Now, the second one is the slip. That is movement along the defined planes. So there is a channel that the debris follows, Then we talk of the coherent blocks. Some moves in terms of blocks, some moves in terms of debris, and we can also not forget the wind. Wind can also cause the movement of the materials from the topmost layer to the downer part, while they are being pulled by the force of gravity. Then we also have what we call the form slides and slumps. And the last one is the fall, which is the free fall of the cliffs. When the materials moves from this, we still repeat and repeat again of our surfaces. So this is a free fall when the materials up here, when they fall down from the cliff to the downer part, and they collect here. Now, looking at that, there is also classification by rate of movement. So by standard nature of the physical geographies or the studies that have been done, so when you have a type of movement, this one, the creep type of movement, this one is always slow. It is slow because it takes time and the environment is normally or is somehow flat. So the earth surface or the materials or the bedrock materials that have been broken from the parent rock materials moves 1 centimeter per year. 1 centimeter per year as shown here. So it takes 1 centimeter movement that is within 1 year. Then the second one is the flow and slides, and that is 1 millimeter per day or 5 kilometers per hour. That is the flow. That is when there is so much mixture and the things that are all the parent rock materials or the debris that are concentrated together are freely movable. So they can move because here it moves in block. It's a big surface, the larger surface area that moves in one. So it takes it 1 year. But when the movement is so rapid, and that is between 1 millimeter per day to 5 kilometers per hour, then it means these are materials that are loosely bound. Then we have the third one, which is the falls and avalanches, and we've talked about avalanches. Avalanches, we've said, is the act of ice or slow moving from the weaker point to the downer part. And you've always seen the mountain, they normally form a cloud, a white cloud whenever they move, and they can also damage people and damage things. They can also be blown by wind. They can also be blown by wind. And then we also have landslide. The landslide. So landslide also are caused as a result of flow, the slides within the blocks, the falls, and sometimes you can call them the avalanches when you are dealing with ice. Remember this one, you deal with ice or snow. The rest you deal with, this one you deal with land and rock. So the major one that has hit Kenya recently was the landslide that occurred in area of Murang'a and the area of the West Pokot and some areas in the northern part. So you saw this happening, and it happened because if you look at how the Rift Valley was formed, there's a cliff, there's an escarpment, and down there's a valley. So that means within the valley there's a cliff which forms a slope of things which can move from the cliff and then they fall. So as they fall, they cause the damage down there. And then we also have the collection or the drainage system that is within. And you can remember that these things, they form some kind of a drainage pattern whenever they are washed away. So you saw so many people dying, and some of them were buried. Even some of the victims have not been found up to today. It's because it is disastrous, it is bad, and so dangerous. So normally the government or the authorities, they normally advise people to move away from the areas that have no bond or the areas that lacks cohesion. So they're normally moved away to a stable areas where the parent rock material is stable. So it's very important that even as we construct or as we pollute our environment, we should always take key that there are certain things that holds the soil together, and we shall talk about these things so as to prevent the act of the landslide or even other activities, human activities that are likely to cause the landslide. So when the land moves from one area down a part, can cause damages. So the landslide takes a bigger chunk of a surface area while it's moving down, and we said that it is very, very dangerous. In that case, I've given you the case of the recent case of the North Rift and the central Kenya in Moraka, where many people were buried. And it is very, very key that we take care of our environment. So if we take care of our environment, the environment will take us. If we destroy it, it will destroy us. And remember, Mother Nature is always superior to us. Is always superior to us. Now, the bottom line of giving up these classifications is that it looks at different examples, or it forms different organizations of these materials to be either washed or be part of the mass wasting. So the next thing we are looking at are the types of mass wasting. So let's look at the types. We've looked at the classification, what causes mass wasting, and now let's look at the types. Number one type is the slums, and as the definition gives, the ones that you can see on your screen, is the movement of mass rock of unconsolidated materials as a unit along the curved surfaces. So if this is a surface, and this is our area, you see, like that. This is a cliff. This is the lowest part. This is the lowest part. This is the highest part. And then this is moderate. So materials move here, down here, and then they're washed, they're taken to the lowest point. So this place is a curved surface. So it occurs along the steep slopes. So this slope must be steep. It must be steep. And we said the one that is steep, that means it has a sharp angle. It has a sharp angle compared to a surface area that is flat. So this is not steep. This one is steep. So it consists of soil and regoliths with a large amount of water, often confined to channels. You see, what happens here, when this place is curved, and then we have a cliff here, this is the lowest point. All the materials are washed here, and probably this is a river. So this is the channel that is formed. So it is moved by water here. So it is confined to the channels, and that's why we talk the channels. These are drainage system. Then the other one is material flow. The material flow, that is like the viscous liquid. So with this thing, this is what we call the layers or the special type. This can happen when rainfall saturates ash or the debris. When we talk of ash, these are materials that have been pushed out from the inner part of the earth's surface to the outer part. So when magma is pulled out, if this is our mountain, and then volcanicity occurs, they say this is the channel, then this is the mantle, the inner part. So these things are pushed out and then they erupt. When the magma erupts, it cools down to form what we call the ashes around. So it is these ashes that are washed. So when they are washed, they form what we call the debris. So these debris flows down the hill. And if you can remember our first lesson, we talked about the pH of this, the pH of the ashes, and we said the more it contains the silica, the more it is acidic. The less it contains the silica, the less it is acidic. So the pH varies in between 1 to 14. So 14 is basic, and 1 is a very, very strong acid, while 7 is neutral. So when ice and snow are melted during the eruptions, they saturate the ice and the debris, and we have explained how it happens. Then the slips and slides, and this happens to the rock slides. So we've talked of the blocks. We have talked of the blocks, meaning the blocks. If this is a big block of land on a high area, and this one is another one, so due to the forces, there can't be a weak joint. And this weak joint you've seen especially to the formation of the three types of rocks: the metamorphic rocks, the sedimentary rocks, and inorganic rocks. So, for example, when we are talking of the sedimentary rocks, this is a collection of the materials that have been eroded from the sediment, so from the igneous rocks, and the metamorphic rocks. And when you talk about metamorphic rocks, these are rocks that have been formed as a result of heat and pressure. So there is that heat and pressure that pushes them together. So there is always a weak part. So when this is another rock that has been formed, then there is another layer and there is a weak joint. So the whole of this part is likely to move because it has a weak point. And remember, there's a force that is acting against it to push it down. So when it pulls down, it shears, it lacks cohesion, and it falls down. So whenever it is falling down, it causes what we call the friction. And this is what causes the damages. And if there is nothing or there is no living organism, it causes what we call the formation of the new landforms, new physical features. These things can happen naturally, or it can happen as a result of human activities, e.g., we can call deforestation, we can also call mining, and sometimes even war, the use of explosives to hit other people or to detonate other things. So in this process, we weaken the points, or we weaken the rocks, we weaken the slabs. These are the rubs. These are the slides that moves down the hill. So learners, geography is easy, and it's very easy, and especially if you love nature, you are likely to enjoy this lesson, and I hope you're enjoying at home. So let's continue. Another thing is when we are talking of rock slides, because these are solid materials, and the rock slides either comes directly from the parent rock or the solid rock that is of a bigger block. So it may break up into avalanches if it is an ice. It is always very fast and destructive because it is big, and we say the bigger the object, the force, the greater force it attracts. So it's very important. Then we have the current mass movement. This is along the plane of weakness. I've explained that. Then debris, slumps, and rotations. So as they move, they rotate. That is key. Then the other one is the rock falls. When the rocks spills or they split from the parent rock materials, they move freely. They fall down. So whenever you visit a mountain or on a highly raised area, you normally see the collections down there. These are rocks or the debris that have been clipped from their main component, and then they freely fall down. And we said gravity is a force. So we don't have to repeat about the force of gravity because we know it is a common factor that helps us or makes objects pull down. Otherwise, with no force of gravity, we could have been going up and up and up without coming down. So it is key to us, and that's why you obtain the stability. We have the debris falls again. This starts as a current mass, a smaller ones, then becomes a debris avalanches. So it starts smaller. So if this is our area, So with the time, if something happens or erosion happens or weathering occurs, it is slowly. But as it goes slowly, as it splits slowly, it weakens the bigger part. And then later, if there's no cohesion or there's no force that pulls it together, it starts pulling up the bigger ones because they have been exposed to the agents of erosion. So they move down. So the debris can either be in rock form or it can be in form of the bedrocks, the larger blocks that falls down, or the avalanches if you are talking about the ice and snow. We also have what we call the rock falls called talus. The talus, these are aprons of the debris of the broken rocks at the base of the larger cliff, So if this is our surface area, and this is the base, So the talus rock falls almost to the base. They normally fall here because they are either acted upon by the process we talked of the exfoliation, or the agent of erections or of erosions, which can be the water, it can be heat, which causes contraction and expansion. Once they dig or they weaken the base of these materials, once it is weakened, it forms a curve or a cut. So this place remains. In other words, it forms something like this. It cuts down there. So you see here, remains hollow, and therefore these materials, they start to break as they fall down here. So I hope you are seeing as they fall down there. Then we have the slope of the angle, or we call it slope angle. So the steeper the slope, the higher the shear force and less stable. And we've demonstrated that if there's a place that has a steeper slope, the movement is faster. While if it is curved or slightly curved, or it is somehow flat, and remember we said the earth surface, there's no place in earth surface that has a flat or has a straight line. Then that's when we talk of the slope, we talk of the relief, the differences in the highest level and the lowest elevations. We also talk of higher relief, moving masses of build up the momentum and speed. So the higher the materials accumulates up there, the more it becomes unstable, and therefore the force of gravity becomes lower. And you see, later when we'll be still continuing with our discussion over the physical geography, we will look at what you call the layers of atmosphere. We'll see where the gravity force reaches, where it is stronger and where it is weaker, from the stratoforce, exosphere, the mesosphere, the xenosphere, and even the stratosphere. So we look at the layer of the atmosphere, and you see where does the ozone layer lays, and where does it stop, and what separates them. So where is the force of gravity stronger and where it is weaker. So we'll look at this, and as time goes, and that's why I'm telling you, geography is good, geography is sweet, and geography it is easier to understand when you concentrate. So learners, take note that this is a very, very good subject, and it helps you shape your environment at home. You know that this is the way to conserve it, to prevent mass wasting. We should plant trees and all that, and we'll come later and see the benefits of preventing mass wasting, because it is the sweetest thing to do when you conserve the environment, to protect the topmost layer of the Earth's surface. So let's continue. There's another thing, that is the rock type. The different rocks are made with different materials, and that's why we've said there's igneous rocks, there's sedimentary rocks, and there's some metamorphic rocks. So these three types of rocks have been formed differently with different materials under different conditions. So it's like sedimentary rocks is a collection, and then there's compaction that occurs over time. And we've seen an example of sedimentary rocks, especially the ones that are found along the riverbed or down a part of the hill, or sometimes the collections that remains as a result of the earth movement processes, or let's say the volcanicity or the earthquake that has occurred. So it's the material that split up and form another type of rock, which are known as the sedimentary rocks. And then we say metamorphic rocks, it is heat and pressure that makes it. So different rocks have different strengths of cohesion. So it depends. So the ones that are loosely bound, they are likely to be washed away. The ones that are solid, they are likely to remain in situ. But the ones that have bigger cracks, with the larger landmass, they can easily move slowly by slowly. And they've said if it is moving in a larger, in bedrock, then it takes probably 1 centimeter per year. It moves 1 centimeter per year. So viewers, when you're experiencing this 1 centimeter per year, we might not notice it that this thing is happening. Maybe you don't know, but your home, maybe your home has been moving 1 centimeter each and cropping to other person's place. So let's take note that the earth process is a constant thing, and it keeps on happening day and night. So that is a process of it. Then let's look at the other side. We want to look at what you call the factors that influence mass, the ones that we have just talked right now. We've talked of them about right now. There's another one called the vegetation, and we've talked of vegetation. Learners, since primary school, or even to those who have not gone to school, it's a common knowledge that planting trees or vegetation cover protects the land surface. So when we talk of the vegetation, the roots hold up the soil together to prevent them from breaking. In other words, it causes what you call the cohesiveness or the cohesive force that brings them together to prevent them from breaking away. So you'll see there's a highly accelerated rate of erosion to a surface where there is no vegetation. But if there's vegetation in an area, it protects it and protects it from the agents of correct erosion. It also protects it from the damages and also the external land processes such as mass wasting. So vegetation is a key factor in preventing our soil, in that it creates an impact, or it compacts together the soil, holding them together to prevent them from slipping away or from being acted upon by the agents of erosion. The other one is climate. The climate. So when we talk of climate, there's freeze and thaw, which I've explained, the expansion and construction of the materials. The melting, when we are talking of avalanches, the melting of the ice or of the snow. We also talk of precipitation, that is rain. Rain can hit a ground and loosen the cohesion. So the more the rain, the more it causes the breakages, and it is these breakages, the broken materials, that are moved in mass wasting. So rain is another important. So when it rains, when there's a season where rainy season is not frequent, then the soil is likely to hold. But when there's excess rain, that means most of the material, the particulars, are dissolved. And when we talk of rain, we also talk of these rocks sometimes are made of chemical factors. So there are chemicals that are soluble. So if you have a rock that has, so let's say for example, that has calcium or sodium, we have calcium carbonate, and you know that calcium carbonate can be dissolved. So if you add the HO2 and the C and the CaO3, then this is likely to dissolve it. So when the chemical structure of a substance changes, then it weakens the bonding of that kind of object because some of its parts has been dissolved. So when the rain season comes, the materials are dissolved. So once they're dissolved, they weaken the bonding, therefore leading to the easier movement of the materials because the chemical structure of these rocks, the structure of it has changed and it's no longer the original object or the original soil that has been there before. So take note that there are some chemical substances, some compounds that have been formed as a result of the combination of some elements which can dissolve or which can be dissolved in water as a result of raining. So let's take care of our environment and know that when the rain comes, there can always be damages, but it depends on how we handle it. Now, the second one is the heavy or intermittent precipitation. Precipitation is still rain, which can enhance mass wasting, and we've said the more the rain, the more the destruction. But if it is moderate, that means it has less destruction. So the less vegetation, the quick saturation. So that's how we talk about it. Vegetation, very important. Plant cover, that is very, very important. It even reduces the strength of the rain. When the rain hits the ground, it takes up the impact between the rain and the soil. So it makes the plants receive the impacts first before dropping into the soil. So rain and plants are good together. If they are combined together, they can easily protect our environment and slow down the erosion. Then we also have potential planes of weaknesses, the foliations we talked about, the metamorphic rocks, which are formed as a result of heat and pressure. Then we have the bedding, the sedimentary rocks, the ones that are collected as a result of the breakages from the other rocks, which includes the igneous rocks and the metamorphic rocks. Then we also have sheet joints, the cooling joints, and the fractures. So the fractures or the cooling joints act as a weak point of materials slipping away from their original form. We also have unstable planes or perpendicular slopes, slopes that are sharp, these ones. So materials can easily be drawn down here, and that's why we talk the perpendicular slopes. So perpendicular is a vertical line, but it's somehow inclined. So this one attract more gravitative force. It is more. This one moderate. Then this one can be extreme. This one can be moderate. Then this one can be slow. So all these are the perpendicular inclinations or the angles of the slope. Then the general rule of these factors means that if planes are oriented perpendicular to slope, system is more stable. If planes are oriented perpendicular to slope, system is more stable. That means the more the slope is steep, then it means there is so much mass wasting. But if the slope is even, or it is slightly raised, or the angle of the surface area and the yield is bigger, then it means the materials can easily move slowly compared to the ones that are steep. Then we also have what we call the debris thickness and addition. And the thickness, we talk of the bedrock. If it is thick and it is big, the weight is more, and it is likely to hold large quantities of water, and this can lead to the movement down. Then we also have force applied on slope. That's another factor that prevents it. Then the last one that causes it is the earthquake and volcanicity, and we've talked about the earthquakes disrupting the solid part of the rock. Then we also have volcanicity, which is the eruption of the magma from the inner surface part of the earth to the outer surface part of the earth. Now, the mass wasting has hazards, and as I told you, it can always cause problems if it is not taken care of well. It can lead to distractions, and this is important for us to look at how it is. Now, as we are going, I have seen some questions that have been asked. I've seen some questions that have been asked, and the key. There is Kabia from Kipipiri. He's asking, what if an exam, what if this question was asked in an exam? Identify the implication of mass wasting to the local environment, and how am I going to approach the question? Kabia, this is an easy question, very easy. Actually, I'm very glad that you are even in Kipipiri, where you're close to the central region there. You've heard of what happened. There are so many implications that have occurred as a result of mass wasting, and that is the destruction of life, even the losing of the topmost layer, the richest part in terms of nutrient, the agricultural land that is washed away. That is very, very important, because it can cause hazardous environment. It can even expose other things, that even the bedrocks that cannot be used for agriculture, the ones that are not useful. Then there is Isaac from Makindu is asking to explain 5 ways in which soil creep occurs. So soil creep can occur. One, there's a key factor that we've said is water. Once the upper surface is concentrated with water, then it detaches from the parent rock materials. So when it detaches, then it means that the upper part of the area is saturated with water. So once it's saturated, it starts moving. And we will also come to give you the points that occurs under these circumstances, and especially to areas that are prone to water or the drainage system. Then Rumuruti, somebody from Rumurutu is asking to elaborate more on shear and strength and how it influences the mass wasting. So we have shear. I've talked of shear and strength, and when you talk about shear and strength, first you take the force of gravity. And you see, when you have strength is that cohesiveness, the force that holds the debris together, or it holds up the parent rock together. So once it is loaded, or it is logged with water, or other means of erosions have occurred, let's say from weathering, this chemical, physical, or it weakens it. So when it weakens, it shears, it moves away from the main parent rock materials. So when it moves away, it creates what we call the frictional force that can either damage or slips away. And remember, it all happens as a result of the creation of the weaker link or the weaker surface that has occurred. So there's larger part, there's upper part that has been concentrated with water, or this upper part that has been separated as a result of freeze or thaw, contraction and expansion of the material. So when it slips away, it causes that force. And I'm glad you've identified that, and that's how it occurs. And there's also one person who is asking, explain the factors that are responsible for rapid mass wasting. Those factors that are responsible for rapid mass wasting can either be physical, or it can either be man-made, or it can either be natural. When you talk of physical and natural go together, when you talk about them is when there's excess water, the excess rain, the saturation is high. And I gave you an example of making a paste with a mud house. So one is the materials that makes up the object. If it is less or it's highly soluble, it can easily fall down. It accelerates mass wasting. Two is lack of vegetation, which holds the soil together or the debris together. It can also accelerate it. Another is climatic conditions, which include rainfall. So when the areas that experiences hailstones, so this hailstone, when they eat the debris or the materials, they can easily accelerate it. There's also what we call the gravitative force. That's another thing. The gravitative force acts on two things: the steepness, or we can say the type of slope, the angle of the slope. So if the slope is steeper, the higher the mass wasting. And if the slope is less steep, then it means there is less mass wasting. So those are the figures, some of the factors that accelerates mass wasting. The last one is Shadrach, who is asking the evidence of soil creep. So the evidence of soil creep can be found in various forms. Number one is the concentration of the debris. For example, the original materials that used to occupy the area, showing some sign of changes. Again, you can see some wrinkles being formed. There's some layers. An example that I can give you is if you see a surface was like this, and the debris have been moved down, you are likely to see some kinds of materials. You'll also see an area that materials have been withdrawn from, being empty or showing some sign of being swept away. You also see foreign materials that have been generated from the area, other areas, materials that have come from other areas of the foreign materials to this area. You can also see what you call the wrinkles. The wrinkles is a soil like this, depending on the direction of the slope. Again, you look at what you call the deposition, and that's why I've talked of the foreign materials. So look at that, and it forms the conclusion that mass wasting has occurred. So as we are going on, let's look at the hazardous ways in which mass wasting has caused. So what to look for? What are the signs that you can consider when looking at mass wasting? So number one is you look for signs of creep or any mass wasting, the sharp, hammocky, or toes. You look at the appearance of the area. Again, the panes of weakness, and I've told you that the panes of weakness, these are layers that have ever been cropped in, or some chemical elements have been withdrawn from them, and therefore they gives up the cohesiveness or the force of holding together. So they form some lines of weaknesses. You can also consider the consequences of steeping slope, as making roads or landscape. So you can see that. Then you can also be aware of the removal of vegetation. Again, what to look for or to consider is addition of weight. And we've said weight acts a lot. And then, how do we prevent mass wasting? Number one is by stabilizing slopes. You can stabilize slopes by planting trees. You can plant trees around. You can allow the vegetation to grow. You can avoid agricultural activities. If, for example, now there are two systems of planting, and one has been discouraged. When you are plowing across or along the counters, so you need to consider the direction. So instead, for example, if this is your area and those are the lines that I go, these are the lines, counter lines. So don't plow across your land like this. Rather, you should plow along the counters, and within these lines you plant the stabilizers, those vegetations that acts as a stoppers that prevents the erosion going down. Each has to be planted. So you plant along, not across. You plant along it, not across, right? Then bolting of rocks together, the bedrocks, just to prevent it from cracking and you've seen this with the construction companies, and we as people, sometimes we should also take care of environment at the expense of our development. You see, if you've seen people mining in areas, and these areas sometimes they end up breaking, people losing property and life. So it's always, sometimes we be conscious of ourselves in protecting the bedrock, because it is key for us. It is key for us to maintain the kind of bedrock, because it's what holds us. If we destroy it, it destroys us. There's also removing unstable slopes with planes of weakness. We can also minimize extra weight. For example, the construction of the building. So you cannot, for example, find an area that is slightly raised and then you build houses of stories. These houses are likely to break. They are likely to break because you've added weight on an area that is not stable. So for you to stabilize it is, do not construct houses there, or do not construct or have any kind of development that adds weight to the area. Another one is minimizing. That one you've said, minimizing. Another one is by supervising all the chemical materials that are released. So whenever we supervise the chemicals that are released, then they are likely to prevent the movement of the materials from their main parent rock material. So it is very important to do that. It is very, very important to look at that. Now, learners, as you have seen this topic, it has been an interesting one, telling us on how the movement of materials, the movement of the debris, or we can say an accelerated erosion of the materials that are moved from one point to another as a result of the force of gravity. And we have said that it is this process of the movement of the eroded material from their point of origin to their point of deposition. This is what we call the mass wasting. So this process occurs as a result of the force of gravity, and it is with us we've seen it, how it occurs. Now, it's upon us to take care of our environment and see how we can protect it by avoiding these issues. We've looked at the types of the mass wasting. We've also looked at the formation and the classification of the mass wasting. So even as you are preparing for your exam, make sure that you read broadly, you read other factors that can also cause it. You also challenge the knowledge that has been put forward, because knowledge is constant, and it is very, very important that we keep on innovating the new ways of identifying other things that can cause the environment to change. So it's us to read, not just for the purpose of passing the exam, but it's also for the purposes of preventing our Mother Nature from hitting us. So let's take care of our environment, let's do a good job, and the environment will reward us back. So as I've told you, we shall continue with the physical geography in our next lesson. Take care of yourself now that the country has been opened up for the inter-county movement. Take care of yourself, take care of your health, because we need you in this exam. Thank you so much.